What if I told you there's a drone so advanced it can hover outside your window for hours, and you'd never know it was there? No rotors, no noise, nearly invisible to radar, and it's already being used in real combat situations right now. Stay with me, because what you're about to learn will change how you think about drone technology forever. Hey everyone, welcome back to the channel. Today we're diving deep into one of the most fascinating developments in unmanned systems, the capsule drone. This isn't science fiction. This is real technology that's redefining modern warfare. And by the end of this video, you'll understand exactly how it works and why it matters. Before we get into the technology, we need to understand why this was developed in the first place. Let me paint you a picture. Israel is roughly the size of New Jersey, surrounded by countries that have historically been hostile. With a population of just 9 million people, they can't rely on having more soldiers or more equipment than their adversaries. So what do? Well, they innovate. For decades, Israel has operated under a simple principle: win the battle before it starts, through superior intelligence and precision. That philosophy has made them a global leader in defense technology, and the capsule drone is the perfect embodiment of that mindset. Think about traditional military drones for a second. The Predator, the Reaper, these are massive aircraft. They're loud, they're visible, and they require significant infrastructure to operate. But what if you could shrink all that capability down to something a single soldier could carry? That's exactly the question Israeli engineers asked themselves. And the answer they came up with is brilliant in its simplicity. Traditional quadcopters have 4 exposed rotors, angular bodies, they're visible from a distance, and they make a very distinctive noise. Capsule drones are completely different. They're smooth, football-sized shells with enclosed propulsion systems. They're nearly silent, and they have a minimal radar signature. This isn't an incremental improvement. It's a complete reimagining of what a tactical drone can be. Now let's get into the engineering, because this is where it gets really interesting. That smooth, curved shell isn't just aesthetic, it's functional stealth technology. Radar detection relies on radio waves bouncing back to a receiver. Sharp edges, flat surfaces, and exposed mechanical parts create strong radar returns. They basically shout, "I'm here!" But a smooth, curved surface scatters those radar waves in multiple directions, creating what's called a low radar cross-section. From a detection standpoint, this capsule looks like a bird, or nothing at all. It's the same principle used in stealth fighters like the F-22 and the F-35, but miniaturized into something you could fit inside a backpack. Now you might be wondering, how does it fly without visible rotors? The propulsion system is fully enclosed within the shell. Depending on the model, it can use ducted fans, micro-turbine engines, or electric propulsion combined with sound-dampening materials. The result is astonishing. At just 50 meters away, the acoustic signature is virtually undetectable in an urban environment. It disappears into background noise like traffic, wind, and people talking. Think about that for a moment. A surveillance or strike platform hovering outside a third-story window, and the people inside would never hear it. And then there's the navigation system. This isn't just GPS, because GPS can be jammed or spoofed. These drones use what's called multimodal navigation. They constantly map the environment in 3 dimensions using visual simultaneous localization and mapping. They track movement with inertial sensors, they match terrain against preloaded maps, and they plan paths in real time to avoid buildings, trees, and power lines. What this means in practice is simple. You don't need to be a skilled pilot. You tell the drone to go to a specific building and scan a specific floor, and the AI figures out the safest, quietest, and least detectable way to get there. But here's where it gets even more interesting and slightly unsettling. The real power isn't in the capsule itself, it's in what you can put inside it. And this modular payload system is genuinely revolutionary. Inside the capsule is a configurable payload bay. Before a mission, operators can tailor the drone exactly to the task at hand. In an intelligence, surveillance, and reconnaissance configuration, the capsule becomes eyes in the sky. It can carry high-resolution cameras capable of reading text from hundreds of meters away, thermal imaging sensors that see heat signatures through darkness, fog, and even thin walls, low-light cameras that function in near-total darkness, and laser rangefinders for precise distance measurement. A single capsule in this mode can monitor an entire city block continuously for hours. In a signals intelligence configuration, the drone becomes a flying electronic spy. It can detect and locate radio transmissions, identify and geolocate mobile phones, map Wi-Fi networks, intercept communications, and even detect enemy drones by their control signals. Hover one of these over a suspected enemy position, and you can build a complete electronic map of their communications infrastructure. Then there's electronic warfare. This is active disruption. The capsule can jam communications, block radio frequencies, spoof GPS signals, confuse radar systems, and even jam or take control of enemy drones. In urban warfare, this allows operators to isolate a single building or block without affecting the entire city. And finally, there's the most controversial configuration, precision strike. These capsules can carry small warheads, typically 1 to 2 kilograms of high explosive. They can use shaped charges designed to penetrate specific targets, fragmentation options for anti-personnel use, and laser or GPS guidance that ensures accuracy within centimeters. The key word here is surgical. This isn't about leveling buildings. It's about neutralizing a specific threat with minimal collateral damage. So how does this actually play out in the real world? Let's walk through a realistic operational scenario. Intelligence indicates a high-value target is meeting with operatives in a dense urban area. Civilian presence is high. Traditional options are limited. Airstrikes cause too much collateral damage. Artillery and missiles are politically unacceptable. Ground assaults put soldiers at risk. Traditional surveillance struggles to keep track of a moving target inside a building. This is where the capsule drone comes in. A team positions themselves several kilometers away. They program the mission parameters, including the target location, surveillance objectives, rules of engagement, and fallback plans. The capsule launches quietly. To bystanders, it might sound like a car door closing. Within seconds, it's airborne. The drone navigates autonomously, flying low to avoid radar, using buildings for cover, adjusting its path in real time, and maintaining encrypted communication with operators. It arrives undetected. Once in position, it can land on a rooftop, attach to a wall, or hover outside a window. For hours or even days, it feeds intelligence back to command. High-resolution video, thermal imaging showing how many people are inside, audio if windows are open, electronic signatures from phones and devices. Commanders can confirm identities, assess civilian presence, and wait for the optimal moment. If a strike is authorized, the decision is made by humans, not AI. The warhead is armed remotely, and the capsule executes with precision, or the intelligence is used to guide a ground operation. Afterward, the drone can return for reuse, relocate, or self-destruct to prevent capture. The entire operation is silent, invisible, and deniable. But now imagine this, not one drone, 50. This is where swarm technology changes everything. Instead of individual drones, you get a network swarm with distributed intelligence. Each drone acts as a node in a mesh network, relaying encrypted data. If one loses contact, the others compensate. Using AI inspired by nature, the swarm spreads out, avoids collisions, shares sensor data, and adapts collectively to threats. Covering a 10 square kilometer area becomes trivial. If one drone detects something suspicious, others converge automatically from multiple angles. The AI filters out false positives and highlights genuine threats. To the human operator, the picture is clean and clear. This level of persistent surveillance was impossible just a few years ago. For border security, it's a game changer. For urban warfare, it's overwhelming. For the enemy, it's like fighting an omniscient opponent. And this isn't just about Israel. Every modern military is watching closely. The United States is investing heavily in similar systems. European forces see this as a way to compensate for shrinking budgets and manpower. Even non-state actors are paying attention. This technology is powerful and it's spreading. Which brings us to the difficult questions. Does precision make war too easy? If there's no risk to your own forces, does the threshold for using force drop? What happens as pressure grows to give AI more authority, especially when decisions need to be made faster than humans can react? And what happens when this technology proliferates beyond state control? There are also serious concerns about privacy and surveillance. If this can protect borders, it can also monitor citizens. These aren't hypothetical issues, they're emerging realities. But here's something important. This technology isn't just for war. The same capabilities make capsule drones invaluable for disaster response, search and rescue, infrastructure protection, environmental monitoring, and humanitarian missions. After earthquakes, they can search collapsed buildings for survivors. During wildfires, they can provide early detection. In the ocean, they can assist in maritime rescues. The technology itself is neutral. It's how we choose to use it that matters. So where does this go from here? In the next decade, we'll see even smaller drones, longer endurance, greater autonomy, advanced counter-drone systems, and widespread adoption across military and civilian sectors. The age of the silent, smart drone isn't coming. It's already here. The Israeli capsule drone isn't just a new weapon system. It's a glimpse into the future of warfare, security, and technological power. Stealth by design, AI-driven autonomy, modular flexibility, swarm intelligence, precision application. The real takeaway is this. In modern warfare, the greatest advantage isn't size, it's intelligence. Not noise, but silence. Not just power, but precision. Understanding this technology is how we take part in the conversations that will shape our future. If you found this breakdown valuable, hit the like button, subscribe for more deep dives like this, and let me know in the comments what you want to explore next. Thanks for watching. I'll see you in the next one.